Hey guys, this is David Pham here. Welcome back to my YouTube channel. As you can see, I don't have my portable mic today. I kind of broke it, but good thing this classroom has this built-in mic over here, which is pretty neat. Today, we will be covering intervals and set builder notation. So without further ado, let's begin. So essentially, set builder notation is a shorter way to write sets that are too large or infinite to write by hand. If I were to tell you to write a set of all real numbers to me, you probably wouldn't be able to do that because you would have to write every number in existence that's not complex, and you wouldn't want to waste your time doing that. So, mathematicians invented something called set builder notation to ease the process. So here's an example of a set that is defined using set builder notation. I gotta step away from the mic because I'm pretty sure I'm gonna cover everything.
So this set over here, we're just gonna call it set A. It's just a normal set, don't be alarmed yet. It still has the curly braces and everything, but the stuff on the interior is a bit different from what you would expect. What is enclosed in the curly braces is just the description of the set. Because the set is so large, we didn't want to write every single element inside of it.
So in English, this set is read as A is the set of all real numbers x such that x is greater than 0. So there are two parts to the description of the set, divided into two with that colon over there. Some people like to use colon or vertical bar, it doesn't really matter.
So the first part here, you might recognize this fancy E. So all this part is saying is that all the elements in this set belong to the realm of the real numbers. This part is just a general indicator of where the elements are, what their type is. After the colon or the vertical bar, whatever you like, this states the restrictions that each of the elements must have.
If both these properties are satisfied, then they belong in that set. Now, a quick note here, you don't have to use the variable x to describe each element in the set. You could have used any other letter. Same thing goes for the name of the set. I didn't have to name it A either. Let me give you another example. So, another example I'm throwing at you here is the set B is the set of all integers y such that y is greater than or equal to 0. Now, if you've caught on, this set is actually equivalent to the set of natural numbers. So here's another example of a set with no name this time actually, used with set builder notation, that is actually really short. In fact, it only has 5 elements in it. This is the set of integers x such that x squared is less than 5. Pause the video for a second and see if you can find a set equivalent to that on the board without using set builder notation. I just want the 5 integers. Alright, I hope you have the answers. The integers are -2, -1, 0, 1, and 2, as those are the only integers squared result in a value less than 5. So now that we've talked a bit about set builder notation, let's move on to intervals. So an interval is essentially all the numbers between two specific given numbers in the domain of real numbers. Intervals are a very fast and condensed way to represent a large quantity of numbers, and they can also be expressed in set builder notation as well. Let me show you how they work. So explaining how intervals work without being too rigorous is actually a bit difficult, so I'm going to introduce some variables to help me out. Now, the statement on the board might seem a bit complicated to you now, but it will be a very important tool once we move on to logic and proofs. So to help me explain to you what an interval is, I'm just going to let two random variables, a and b, exist in the realm of real numbers. I'm introducing two arbitrary real numbers, which can be anything they want as long as they're both real numbers, and such that the real number a is less than or equal to b. Now, this notion of arbitrary might seem very abstract to you, but just let a and b be any two real numbers. Alright, so for the first example, say we wanted to capture all the elements from A to B, including A and B themselves. If you're familiar enough with set builder notation, that's how it should look like. In the interval form, all you would have to do is put the smallest number of the two on the left, followed by a comma, and then the other number that you want to capture the range of, and surround them in square brackets. When you surround them in square brackets,
You're saying that you want to capture that interval, including the endpoint itself.
so next, what if we want to capture an interval without the endpoints? As you can see in the set builder notation, the crocodile hands, they don't have that line underneath it. Recall quickly that greater than or equal to and just greater than are two completely different things. Say we wanted to capture an interval from the numbers 0 to 4, but not including 0 and 4. We'd still want 0.0001 and 3.999, but not the endpoints. So instead of the square brackets, you would just use the normal round brackets to indicate that you do not want the endpoints. Now, you don't have to use one or the other. You can actually combine them as well. Say you wanted one endpoint but not the other, that's okay. On the board, I've written both scenarios and how they would be written in an interval and set builder notation. A quick note again, it is always good form and very important to put the smaller number before the larger one in both interval and set builder notation. So finally, let's talk about the concept of infinity and beyond. Let's say we want an interval or a set with only one endpoint, and then it goes on forever. So going back to set builder notation, the first example right there is asking for a set of all real numbers x such that x is greater than or equal to a certain point or real number a. Looking at the number line to your left, there is one endpoint a, and from there, it just goes off in the positive direction forever. So to express this in interval form, we use the infinity sign to display that it goes on forever in that direction. Similarly, in the second example, we want a set of numbers that are less than an arbitrary cut point b. So this means that starting from b, it's going in the opposite direction. It's going in the negative direction. Since it's not going in the positive direction, it's going in the negative direction, then the interval is from negative infinity to b. Now the trick here for beginners is that you shouldn't make that big of a deal of infinity. What you have to remember is that infinity is not a number. We just know that it goes in one direction forever. And as long as it's less than or greater than a certain arbitrary number, all we have to do is make infinity exclusive, aka those round brackets that you see. You can never include infinity because it is not a number. So this is just a quick recap of all the symbols that you'll see in intervals and set builder notation. So these square brackets are called inclusive. That is when you want to include the number at the endpoint. And the round brackets are called exclusive. You do not want to include that endpoint. So the interval I've written up there is read as the interval from 4 inclusive to 7 exclusive. And at the bottom are the big crocodile hands, which just mean greater than or equal to or less than or equal to, depending on whether or not you have the line underneath the crocodile hand. And yes, I'm using the crocodile hand analogy because that's what I've used in elementary school. So finally, before I end this video, which has been dragged on long enough, I'd like to point out that intervals and set builder notation can also be used with the union and intersection symbols that we learned during the last video. Now these can be a bit tricky and can fool you, so I would watch out and look at everything very carefully. So I've written an example on the board here. This is an interval asking to capture all the elements from negative infinity to 2 exclusive, or from 3 inclusive to positive infinity. And I've even drawn a small number line visual representation there to help you out. So to write this in set builder notation, the answer would be the set of all real numbers x, such that x is less than, strictly less than 2, or x is greater than or equal to 3. You don't even have to write infinity. We know that it's either going in one direction or the other. So here's another example for you to try: the intersection of the intervals negative infinity to 0 inclusive and the interval negative 4 to 0 both inclusive. Pause the video and give it a try for yourself. This one's a bit tricky. So if you haven't noticed, the interval negative 4 to 0 both inclusive is actually already in the interval from negative infinity to 0 inclusive. So in reality, the set of intervals with the intersection is actually equivalent to just the interval negative 4 to 0 both inclusive. So in set builder notation, we're just looking for all real numbers x that are in between the domain negative 4 and 0. So that was it for this video. Thank you guys very much for watching. As always, I've left some questions for you guys to answer. Answers will be in the description, as well as any additional resources that might help you understand intervals and set builder notation better. If you have any questions, please don't hesitate to write in the comments. I will do my best to answer all of them. Don't be scared. If you have any additional feedback on how I did, please leave those in the comments as well. And any suggestions for future videos can be written in the suggestion box that I will leave in the description as a URL. Thank you guys for watching, and I'll see you in the next video.